partner, and thank you to everybody who uses S3 and Glacier today, and there are many of you. So S3 and Glacier manage exabytes of storage, tens of trillions of objects. And we do that across many millions of drives in our data centers. Just to give you a sense of that scale, in a single region, S3 will manage peaks of 60 terabits per second in a single day. And that rate of growth is driven by the incredible variety of unstructured data that you store in S3 and Glacier. And that ranges from the source data of data lakes to driverless car storage to genomics research. It's an incredible variety, and people store it in S3 and Glacier because it just works. So I could easily spend the rest of this keynote talking about the internals of S3 and Glacier, but I am going to focus on one aspect, which is data durability. Let's start first a little bit back in time. And when S3 was first launched almost 13 years ago, S3 had 8 microservices. Those microservices did things like serve requests for objects, it stored object keys, and it did the metering and billing for both requests and bytes. And of course, it orchestrated the replication of storage across physical data facilities. Now, more than 235 distributed applications make up S3 and Glacier, and they're all working together to deliver a single customer experience behind that endpoint. And, as is the nature of a distributed system, our microservices do one, maybe two things really well. And as an example, one of our microservices has nothing to do but prepare and bring online new drives into the service. But today, what I'm focusing on is really durability. And the reason why I wanted to talk about this is that it's so core and central to our commitment to your data. It's not just the systems that we build. We think it is just as important to have a culture of durability. And that's what we bring every day to what we build for you for S3 and Glacier. I'll give you an example. For every new feature that we build, and for every major internal change, we do a durability review. And a durability review is very similar to a security threat model. But rather than modeling the risks of intrusion, we're modeling the risks of loss of data. We're looking for things like hardware-based corruption in the network and on disk. We're looking at operator interaction with the system. We look at many different things, and just like a security threat model, we put in place software, processes, and mechanisms to protect against that loss of data. I'm going to cover just a few of the things that we do to give you a sense of it, but there's many more that we do as well. So we talk about how can we put operational safeguards in place so that inadvertent error of an operator doesn't cause any inadvertent loss of data. We make extensive use of integrity checks through checksumming throughout the system. And checksums are important because it helps us prepare, or it helps us prevent or look for uncorrected bit flips in RAM. And when we use checksums, we do them in two ways. One is we run checksums end-to-end throughout the system. We run them from S3 clients all the way back to data on disk. The other thing that we do is we do point checksums between loosely coupled systems. Another place that we look for is correctness of algorithms. This is incredibly important in a large-scale distributed system. And so we have different things that we do here. Sometimes we'll do a formal proof of how an algorithm is mapping out. We'll do static analysis tools like TLA Plus to validate a distributed algorithm. And we'll do flow diagrams that maps out the execution of different algorithms across systems, different systems that we work with. That's all about the correctness of the algorithms that we put in place. But we don't just trust those tools. We have independent auditors. We call them durability auditors. And they're systems, they're microservices that we build that constantly and repeatedly visit every byte in S3. And keep in mind, we have exabytes of storage. These durability auditors are visiting and checking for those integrity checks that we talked about. So just as we talk about these systems, really for us, underlying everything you see here and all the rest of the services and the processes we do is that culture. It's the mindset of what we built. Now, fundamentally, S3 and Glacier are built on fault tolerance. So our software has to account for the natural failure rates of drives and hosts. But we're unique because we also account for an extra dimension of durability, which is the total loss of a data center, a whole building in a region. And we build our software and we account for our capacity so that you can still retrieve your object in that case. So let's start first with what sits inside the data center. Fundamentally, at the heart of our design for durability is our former durability model, which is basically math. It's math that characterizes the risk of losing data over time given the natural failure rates of drives and hosts. What's unique about S3 and Glacier is that we have built almost 13 years of operational experience at scale into that durability model. We're constantly updating it, and we're updating it with the real-world observations and lessons we see in all of our regions. Now, there are two main concepts in that durability model. One is the time to fail. The other is the time to repair. The time to fail is basically the rate at which hardware fails. And hardware, again, is both hosts or servers and drives. Time to repair characterizes how fast we can rebuild the data that was on the failed hardware. Now, keep in mind, this model is a starting point for how much physical redundancy we have in place in a region to keep data safe from these natural failures in hardware. Now, the durability model is a design tool for building our software. And where theory meets practice in a very large distributed system is repair. We don't reason about mean time to failure in S3. For us, it's all about the actual time to repair. And in the actual time to repair, we account for detection of what to repair, as well as the repair process itself. And we look at the worst case scenario for repair. We don't look at the mean, and we don't look at the best case. We are the most concerned about the slowest bytes to repair in our system, because our mission is to protect all your data, not just the average case. So we take that and we build it into the different microservices that we have for repair. And I have some examples. It's not the exhaustive list. But some of the things that we do as part of that repair processing is we're constantly monitoring proactively and reactively for failure. We're doing seconds-level granularity checks on the liveness of the host. We're doing the checksumming, the strong checksumming that I talked about, which handles data at rest. And for data that's in flight, we do these live inline checks of data integrity. One of the interesting things about S3 is because we operate at massive scale in our cloud environment, we can treat total time to recover as an elastic property. And what that means is, depending on the total time to recover is in a given region on a given moment, we can scale up and down our repair microservices dynamically to account for the target that we want to achieve there. Now, it's not just that. We don't just worry about durability for what sits within the data center. What's unique for S3 is we worry about the loss of a whole data center or the long-term impairment of an availability zone. Now, we have never seen the loss of a data center, but we build our software and our systems knowing it can happen. If you know how S3 works and Glacier works, you know that our multiple AZ storage classes replicate storage across 3 AZs. And in any given AZ, you have at least one data center. And it's a data center building. It's not a floor, it's not a room, it's a whole building. And often we have more than that. The way that we build S3 and Glacier is that our multi-AZ storage classes have enough capacity and redundancy in other AZs in the region to withstand the total loss of a whole building. Now, we know this is a very rare occurrence, and as I said, we haven't seen it to date, but we worry about it, and we include the scaling and the capacity modeling and the software system to handle it so you don't have to. So what does that mean? Just like you have security in S3, you have multiple layers of protection against data loss. You have a culture of durability for S3 and Glacier. And you have a model, a durability model, that's informed by almost 13 years of real-world operational experience at scale. You have all the different microservices of S3 driving repair. And we're constantly innovating there based on those durability reviews and other things our engineers come up with. And you have that extra protection of a loss of a whole building and still being able to retrieve your storage. Now, all that is just part of what sits behind that simple put and get to your S3 bucket. I wanted to say thank you for using S3 and Glacier, everyone, and I'm going to hand it back over to Werner.